I will be filming the solutions to the November 2025 Edexcel Higher Paper 1. This is a really good paper to do if you're currently practicing for your mocks next week, as this is the latest paper that the Edexcel have, as it was the November resit from last year. So it's a good idea to do the paper, and then you can have a look through at the worked solutions and check where you've gone wrong. And I will show you exactly how you should be setting out your working. Okay, question 1. We have been asked to expand and simplify. So that suggests there are two things that we've got to do here, and the question is worth 2 marks. So first of all, I'm going to expand, which means to multiply out my brackets. So I multiply everything inside the bracket, both terms, common mistake, people forget the 6, by the number on the outside. So 5 multiplied by x is 5x, and 5 multiplied by 6 is positive 30. Now that gives me 1 mark already for expanding one of my brackets correctly. One or both of the brackets expanded correctly gives me 1 mark. So 2 multiplied by 7 is positive 14. 2 multiplied by negative x, or 2 times x is 2x. Positive multiplied by negative is negative. So this is still only 1 mark. If I had 14 take 2x correct and this wrong, I would still have the mark there. So the next thing I have to do is my simplify. So this simplifies because I've got like terms that I can collect. So I've got 5x here, and I've got to take away 2x. That's a really common mistake for people to put the answer here as 7x because they see 5 and 2. But you have to include the sign that is in front of the term. So we've got to do 5x, take away 2x, which is 3x. And then I've got positive 30 plus 14, which is positive 44. And that's my answer for 2 marks. Even without working, you would get full 2 marks for this answer being correct. Okay, 1b. I have been asked to factorise fully. Sometimes you might have to factorise again once you've factorised initially. This question you don't have to do that. It's just a single bracket. So I have got to put this into brackets by taking out the common factors, which is why it's called factorising. I like to draw bubbles. An old colleague of mine taught me this method and students seem to really like it. It's visual and it makes everything quite clear. So I've got negative signs, so that's going to go in there. And then I've got to take out my common factor. So let's look at 9 and 15. The highest common factor, the highest number that goes into 9 and 15 is 3. So I'm going to put a 3 in both bubbles. Now I've got to work out what the other factor would be. So what would I multiply 3 by to get 9? Well, 9 is 3 multiplied by 3. And what would I multiply 3 by to get 15? Well, 15 is 3 multiplied by 5. So they are my factors of 9 and 15 with a common factor of 3. And then I've got y squared, which is y times y. And I've got a singular y in my right bubble on my right hand side. So that's it. And now I need to actually factorise. So I've taken out my common factors and I need to see what I've got that's in both bubbles. So I've got a 3 here, pair of 3s. So cross those out and put a 3 on the outside of the bracket. You must have it in both bubbles to be able to do that. I've got a y in both. So I cross those pair of y's out and I put a y here. I look to see if there's anything else that's in both. There is not. So I open my bracket. Whatever I've got left on the left-hand side is 3y. I put this sign here in the middle, so it matches the question, and I've got a 5 left on the right-hand side. So that is now my final answer to get 2 marks. If you hadn't taken out 3y and you just put 3 on the outside, or you just put y, for example, you could get 1 mark for factorising but not taking out all the factors. This is the correct answer for 2 marks. And you can always check by expanding your answer back out again. So 3y times 3y gives me 9y squared, and 3y times -5 gives me -15y. So I've checked my answer is correct. Okay, question C, 1C. Write down the value of 2 to the power of 0. This is often got wrong by students, and they think that anything to the power 0 is equal to 0. But in fact, any number or letter to the power of 0 is equal to 1. So the answer here is 1. And let me just show you an example of why that works. So if I've got 2 cubed, 2 squared, 2 to the power of 1, and then 2 to the power of 0. Let's have a look at what happens. So I've got 2 cubed, which is 2 multiplied by itself 3 times. So 2 times 2 times 2 is 8. I've got 2 squared, which is 2 multiplied by itself twice. 2 times 2 is 4. I've got just 1 2. Well, that's just 2. And if you look at what's happening here each time, the answer is halving each time. So if we go down again, 2 divided by 2 is 1. And that will happen with any number that you try here. So any number or letter to the power 0 is equal to 1. Remember that, and don't lose an easy mark in your exam. Very, very common. Okay, question 2. So now we've got a speed, distance, time question. So Ian cycled 44 kilometres in 2 hours and 12 minutes. Work out Ian's average speed in kilometres per hour. That's really important, which is why I've underlined it there. I've underlined the key information. You can do that in your exam if it helps you. So the first thing that's going to get me my first marks is this is in hours and minutes. That's 2 different units of time. So quite often students will convert this into minutes, but that will not give you full marks. So I need to convert 12 minutes into point something of an hour. So the problem is there are 60 minutes in an hour. So quite often students will put 2.12, which is incorrect because there are only 60 minutes in an hour. And decimals work in tenths, hundredths and thousands, and it's out of 60, not 100. So 12 minutes out of a possible 60, and I've got to work out what this is as its simplest form and then convert it to a decimal. So I look to see what goes into 12 and 60, and I can divide both by 12. You could half it and half it again and half it again. But I can see that 12 goes into both of those, so that gives me 1/5. I've now got to convert a fifth to a decimal. Now, some of you may know that and be able to write that straight away. If not, when you're working with fractions, to convert them to decimals, the easiest way is to make them over 10, 100 or 1,000. Because when you have place value, you have tenths after the decimal point, then you have hundredths, and then you have thousandths. So it needs to be out of 10, 100 and 1,000 to convert easily. Then this side of the decimal, you have units, tens, hundreds, etc. So at the minute it's out of 5. I want it to be out of 10. So if I make that out of 10, I'm going to double it. So if I double the top as well, I get 2 tenths. So I've got 2 whole numbers, 2 hours, 2 units, and I've got 2 tenths. So that is 2.2 if you convert it into just hours. So 2.2 hours. If you've done that correctly, that gives you a mark. One of the marks is for a correct conversion to 2.2. Okay, so your next mark, we've now got to work out his speed. So we're going to need the distance, speed, time triangle. It's a bit wonky, my triangle. Distance at the top, speed and time at the bottom. I'm working out the speed, which tells me to do the distance divided by the time. Now, this is a mark on its own, even if you haven't converted the time correctly. So say, for example, you'd done 2.12, or you'd converted this to minutes and you had 132 minutes. If you'd done your distance, which is 44 kilometres, divided by whatever you had for your time, you would still get this mark for showing that to get speed, it's distance divided by time. So you could have this mark. But we're going to do 44 divided by 2.2 because that's the correct converted time in hours. Now, without a calculator, it's hard to divide by a decimal, so I want to make this a whole number, so I'm going to times it by 10. If I times the bottom by 10, I have to times the top by 10, otherwise it's not an equivalent calculation. So that gives me 440 divided by 22. So hopefully we should know that 44 divided by 22 is 2, so therefore 440 divided by 22 will be 20, just pop a 0 on the end. And you don't need to do anything to your answer. That is your final answer for your third mark. If you wrote 20 on its own without any of this working, you would get all 3 marks. However, it's worth showing you're working out, because if your answer is wrong, you can still get all the method marks for the working. A common mistake when dividing, people think you have to change your answer back, but it's not the same as multiplication. So let me just show you an example of why that works. If I had to do 10 divided by 5, my answer is 2. And if I times both of these numbers by 10, so I'm making an equivalent calculation, I get 100 divided by 50, which is still 2. Well, it gives me the same answer, so I don't need to do anything to my answer afterwards. So that's it. 20 is the answer to question 2. Okay, question 3. So I'm just going to zoom out of my screen a little bit here so we can see the full scatter graph. So I have got a scatter graph showing the stopping distances for some cars travelling at different speeds. And as we can see here, the speed is on the horizontal x-axis and the stopping distance is here on the vertical y-axis. And I've been asked, what type of correlation does the scatter graph show? So there are 3 types. Just got this image here. I could have drawn them, but I thought to save time I would paste them in, and you can see there are 3 types of correlation. So this is showing a positive correlation, this first graph here, and that is when you have both variables increasing. So whatever's on this axis is going up, and this is also going up, so it gives you an upward trend and the points are all increasing together. This one shows a negative correlation, which means as one of the variables is increasing, the other variable is decreasing, coming down, which is why you get a downward trend, and that's a negative correlation. This one, the points are all scattered all over the place, no relationship can be seen, so we say no correlation. So if we look at our graph, this is showing an upward trend like graph 1 here. So all we need to write here, because it doesn't ask me to describe and interpret, it just says what type of correlation. So I just need to write positive. So it's only 1 mark for writing positive. And that's my mark there. If it asks you to describe or interpret, that's quite common, the correlation, describe or interpret the correlation, I would always say what the correlation is, and then you would say, as the speed is increasing, the stopping distance is increasing. And that's your describe and interpret. But we don't need to do that here with this question. Okay, so the next part is we've got another car travelling at a speed of 55 miles per hour, and we've got to estimate the stopping distance, and it's worth 2 marks. There's a hidden mark there for drawing a line of best fit, and as you can see in these diagrams here, it follows the general trend of the points, and you try and make sure you have a similar number of points either side of your line. So we're going to try and get our line of best fit following the general direction with a similar number of points either side of the line. We can then use that to estimate the stopping distance. So once you've got it lined up to, it can go through some of the points and then you could have some either side. You want to try and get it as even as possible. I'm going to draw along here all the way down. So that is my line of best fit. So I've got 1, 2, 3, 4, 5 points on that line. 1, 2, 3, 4, 5, 6 on that line side and a couple on the line. So that's roughly in the right place. They do give you a little bit of margin for error and they give you a range for your answer. So now I'm going to use this line of best fit to estimate the answer to this question. So speed 55 is here on my x-axis. So I'm going to go from here, I'm going to draw a line up and then draw another line across. I'm going to need my ruler again. So I'm going to go from 55 on the x-axis and I'm going to, I'll do this in a different colour so that you can see. I'm going to draw a line up till I hit my line of best fit. Then I'm going to go from my line of best fit across to the y-axis so that I can estimate the stopping distance. So I line up here and I draw a line across from my line of best fit to the axis. So now I can see from looking over here what my estimated answer is. Now this is quite a nice scale because it goes up in ones. It won't always do that, so make sure you check the scale, but I can see on mine it is 68. Now you would get 2 marks if you put 68 on its own without the line of best fit, but it's always good to have it as it helps us to estimate, and if your answer's wrong you can still get a mark for the line of best fit. And again they'll give you a range here, so I'd imagine it would be something like 66 to 70, something like that. Okay, next question. Sanar says it would not be sensible to use the scatter graph to estimate the stopping distance of a car travelling at a speed of 10 miles per hour. The estimate would not be reliable. Is Sanar correct? So we need to say yes or no, and you must give a reason for your answer. So if you just say yes or no, you will not get the mark, even though it's only 1. But every mark counts, especially in these earlier questions. If you're going for those higher grades, you do not want to be losing marks here. So let's have a look at 10. 10 is here. And if we look, there are no points in that region. And the lowest point we've got for speed is 20.5 here. We've got nothing below that. All our points are a speed of 20.5 and above. So therefore, he is correct that it wouldn't be reliable to use. So is Sanar correct? We must say yes. And the reason is there are no data points in this region. Or you could say, it's very difficult to write on here, or you could say it's outside the data range, or another word which is quite tricky to remember is extrapolation, which means outside the data range. So there we have it. That's the end of question 3 for a total of 4 marks. So let's have a look at question 4. So A, B, C and D are 4 containers and they are shown here. Water is poured into the containers at a constant rate. The sketch graphs below show the depth of water in each container t seconds after the water starts to be poured. Match each graph to the correct container. So we need to look at the shapes of the container. A is the easiest, as that's a straight container. So what's going to happen is, as the water is poured into the container, it's going to be poured in at a constant rate, which means because it's a vertical container with no different widths to it. It's going to be a steady, consistent rate. And there's only one graph that shows that, and that is graph 3, because it's a steady slope there, which means the gradient, which is the rate of change, doesn't change. So it goes in at a consistent rate. So container A is going to be graph 3. Now, if we look at B, the bottom here is wider than the middle. So if it's wider at the bottom, it's going to take longer to fill the bottom, then it's going to speed up in the middle, and then it's going to slow down again at the top because it's wider at the top. So we need a graph that's slow, quick, slow. And the slower it is, the lower the curve. If you've got a slope like this, that's quicker. Whereas if you've got a slope like this, it's slower. So it's going to be something slow, speed up, and then slow down again. So if we look, this one, slow, quick, slow. Whereas this one is quick, slower, quicker here. And this is quick and then slows down at the top. So we wanted one here that's slower, quicker, slower. So that's going to be graph 4 here. It's slower, then it speeds up, and then it slows down again. So that's going to be graph 4. So if we look at container C, it's narrower at the bottom and wider at the top. So if it's narrower at the bottom, the water's going to fill it quicker at the bottom, and then it's going to slow down as it goes up. So we want something that's quick and then slows down like this. So there's only one graph that's that, and that is graph 1. It starts quickly and then slows down. So that's going to be graph 1. And then lastly, we've got this container D, which is narrower at the bottom, wider in the middle, and then narrower again at the top, which is the reverse of container B. So if it's narrower at the bottom, it's going to be quick, then it's going to slow down in the middle, and then it's going to speed up again. So if we look, that matches the only graph we've got left that's quicker, then slows down, then speeds up again at the end, which is graph 2. So that's 2 marks. If you've got them all correct, you get 2 marks. If you've got 2 or 3 correct, you can have 1 mark. If you've only got 1 correct, that's no marks, unfortunately, for that question. So that is question 4. Okay, so let's have a look at question 5. 5 marks here, so that's a lot of marks. That's not far off half a grade on a paper. So we need to try and make sure we maximise marks. And there's a lot of information here which can often confuse people. So the diagram shows a rectangular wall 10 by 3.3. It shows us that on the diagram. A rectangular door in the wall 2 metres by 1.5. So all of this information is repeated. That's just telling me what's in the diagram. Zach is going to mix yellow paint and blue paint in the ratio of 1 to 5. So 1 part yellow to 4 parts blue to paint the wall. He will not paint the door. He assumes 1 litre of paint will cover 10 metres squared. So that is suggesting, and it's quite often for a question to say this, we are calculating an area because we have metres squared and we're talking about covering. So we are going to be working out an area here. That's a good place to start. Yellow paint is sold in 1 litre tins, costing £4.75 each. Blue paint is also 1 litre tins, costing £5.50 each. Zach has £20 to buy paint. Does Zach have enough money to buy all the paint he needs? You must show all your working. So you're not going to get all the marks here if you just say yes. In fact, just yes on its own would get you 0 marks. You've got to show your working out. So this is a good place to start because we know we're going to have to work out an area and we know he's not going to paint the door. So let's work out the area of the wall, which is all of this space here, but we're not going to include the door. So I'm going to do the area of it as a whole, and then I'm going to minus the area of the door. So I'll do the area of the door in red so we can see which one's which. So let's do the whole thing, which is the whole wall including the door. So wall plus door, just to make it clear what I'm doing. So I'm going to do 10 multiplied by 3.3. And when we're multiplying by 10, every number just gets one space bigger, so it becomes 33 meters squared. So that's the area of the whole thing. So that's the wall plus the door. Now I'm going to do the area of the door because we don't want the door, so we've got to subtract that. So this is the door area here, and I'm going to do 2 times 1.5, or 2 lots of 1.5 is 3 meters squared. So I'm now going to work out the area that needs to be painted, which is going to be my 33 minus the door, which is 3. So this will get you a mark for working out that there's 30 meters squared to be painted. So now I need to work out how much paint I need. So first of all, I'm covering 30 meters, and I'm told that 1 litre of paint will cover 10 meters squared. So 30 divided by 10 is telling me that I need 3 litres of paint. However, I need it to be in a ratio of 1 to 4. So I need yellow to blue to be 1 to 4. Now it would help actually to have my litres into millilitres. That's going to be easier to divide. So there are 1,000 millilitres in a litre. So this is 3,000 millilitres. So if I only needed 5 millilitres of paint, I would have 1 millilitre of yellow and 4 millilitres of blue. But I need this to be 3,000 millilitres of paint. So I need to see how many 5s go into 3,000. So 3,000 divided by 5. 5s into 3 I can't do, but 5s into 30 is 6. 5s into 0 is 0 and 0. So I need to make these 600 times bigger. So I've got to do the same to my ratio. So 1 times 600 is 600, so I need 600 millilitres of yellow. And 4 times 600, well, 4 times 6 is 24. Put my 2 zeros. I need 2,400 litres of blue in order for my ratio to work. So this is how many millilitres I need of each. 600 millilitres of yellow and 2,400 millilitres of blue. So if we put this back, we've got yellow paint is sold in 1 litre tins. So I'm going to have, if I look here, I've got 600 millilitres, but you can't buy 600 millilitres. So for yellow paint, I am going to need 1 tin. So 1 tin of yellow and 2,400, that's over 2 litres, but not quite 3. But you're going to have to buy 3 litre tins. So I'm going to need, because they only come in litres, I'm going to need 3 tins of blue for his ratio to work as he wanted. So now I know how many tins, I can finally work out the cost to see if Zach has enough. So 1 tin of yellow is going to be £4.75. And I need 3 tins of blue, so I need 3 lots of £5.50. So £5.50 multiplied by 3. 3 zeros are 0, 3 5s are 15, and 3 5s are 15. So it's £16.50. £16.50 for my blue paint. So now if I add up the total, because I have to show all of my working, so I'm going to add that up over here because I'm running out of space. So I've got £4.75. Make sure you line up your decimal points. And I've got £16.50. So 5 add 0 is 5. 7 add 5 is 12. Carry the 1. Make sure you put your decimal back in. 4 add 6 add 1 is 11. And 1 add 1 is 2. So he needs £21.50. That only has £20 to buy paint. So this figure here, along with no, Zach does not have enough, would be sufficient. But you would need to have the correct amount along with no to get the final mark. There are other ways of working this out. But if you've used my method here, you would get a mark for working out the area covered. You'd then get a mark for using your ratio here and working out how much he would need. Then you'd get another mark for working out the number of tins that he needs. Then the total cost of the number of tins would be another mark. And then for saying no with the correct working out would get you all 5. So quite a tricky question and lots of working out there, but a good thing to do with these sorts of questions is to work it out step by step. Okay, so let's have a look at part B. It says here Zach's assumption is wrong and 1 litre of paint will cover more than 10 metres squared. How might this affect your answer? Well, it's difficult to tell because we don't know how much more. It doesn't say 1 litre of paint will cover 15 metres squared. So we say it may affect his answer. But difficult to tell as we don't know how much more, or something along those lines. Difficult to tell. Sorry, my writing on here is terrible. Is that meant to be it? It may affect his answer, but difficult to tell as we are not told how much more paint or how much more it will cover. And that is the end of question 5 for 6 marks in total. Okay, let's have a look at question 6. So we are told the diagram shows 2 quarter circles. We can see that with the same centre. So this must be taken from a full circle. So that makes this here the radius of the circle. Work out the area of the shaded section and give your answer in terms of pi. That means leave pi in your answer. So if you look on your formula sheet at the front, you are given the area of a full circle as pi r squared. Now you must use the full area formula. Big mistake here is students use the circumference formula. It clearly says area in the question. So it's pi times radius squared. So that would be if I have a full circle. However, we've only got a quarter circle, so it's been taken out of my circle, so we've only got a quarter of it here. So we are going to get the area for a full circle, but we're going to have to divide our answer by 4 because we've only got a quarter of the full circle. So in order to get this shaded bit here, the best thing to do is to work out the area of the whole quarter circle you've got, work out the smaller quarter, and then subtract your 2 answers. So let's do the whole thing. So if we're doing the whole thing, we need to use this radius here of 4. So that will give me the area of the whole thing, including the shaded bit. So I'm going to do pi times my radius, which is 4, squared, and don't forget it's only a quarter of a circle, so I have to divide my answer by 4. So I'm going to do 4 squared, which is 4 times 4 is 16. So I can write that as 16 pi because remember we're giving our answer in terms of pi, so you leave that in there. Divided by 4, well 16 divided by 4 is 4. So 4 pi centimetres squared is the area of the whole thing. Now I need to take away this smaller circle. So this is the whole thing here, and I'm going to do the smaller section here. So this time I'm going to need this radius, which is 3 centimetres. So I'm going to do pi times 3 squared, again divided by 4 because it's only a quarter of a circle. 3 squared is 3 times 3, which is 9. So I can write that as 9 pi divided by 4. You can either leave that as a fraction, 9 quarters pi, or how many 4s go into 9 is 2, with a remainder of 1 quarter centimetres squared, which is 2.25 pi centimetres squared. Don't forget to leave pi in. I missed it out there. The pi remains. So I've got 4 pi centimetres squared and 2.25 pi centimetres squared. And now what I need to do is subtract these two. So I'm going to do 4 pi minus 2.25 pi. Now, because they've both got pi in, I can subtract these. 4 minus 2.25 leaves me with 1.75 pi centimetres squared. So that is my final answer. You may have this as 1 3/4 if you worked with fractions instead of decimals. It depends on what you're more confident with. But that is the correct answer for 3 marks. So you'd get a mark for working out either one of these correctly. Then you'd get another mark for showing you need to subtract the 2 answers, and then a last mark, 3 marks, for having a fully correct answer. Again, if you just had this without your working out, you would get all 3 marks, but it's a good idea to show our working in case we get the rest, in case we get the answer wrong. Okay, question 7. It's got a line on a grid and it's asking you to find an equation for the line in the form of y equals mx plus c. So it gives you the general equation. This is for any straight line. Now, we should know what the m and the c represent. Quite often students get these muddled up and the wrong way round. So m is your gradient, and in order to do the gradient of a line, you need to work out the change in y over the change in x. So there's 3 different ways you might have seen this written. So you might have seen rise over run. You might have seen change in y over change in x. Change in x, or you may have seen it written as y2 minus y1 over x2 minus x1. They're all different ways of writing the same thing. The rise is this distance and the run is this distance. Change in y will be the difference on your y-axis. Change in x is difference on your x-axis. And this is just using 2 coordinates to essentially do the same thing. When you've got a diagram, the easiest way to do it is to find 2 points. So I could not use this point here because it's not on an exact corner. That's another mistake people often make. They try and use a point that isn't on an exact coordinate. So that's not going to help you. So let me just get rid of those. What we need to do is pick 2 exact points. So that one there is good because it's on an exact coordinate, -2, 4. And I can go with this one here because that's also on an exact point. It's on 0, -2. And then you draw yourself a triangle. Now you need to be careful here because this line is coming down. So you should know that that's going to have a negative gradient. But if I go from this point here to this point here, I'm going to go down 3 squares. Now, again, this is where it catches people out. Because I've gone down 3 squares, people often write 3 here. That is incorrect because you need to look at the scale. It goes from 4 to -2. So each square is worth 2. So this should actually be 6, and that catches lots of people out. But because it's gone down, again, I have to write -6 because to go from here to here, I am going down 6. And then I'm going across. This time the scale is 1 square is 1 unit, so I am only going across 2. So using my rise over my run, I've got -6 over 2, which is -3 as my gradient. So I can now write this out here, and I'm just going to put y equals x, because y and x stay in your equation. It's only the m and the c that you're going to replace. But we now know that my gradient is -3, so I can put that where m was. I now need to do my plus c. And hopefully you know that that is your y-intercept, or where it cuts, C for cut, the y-axis, or crosses the y-axis. So where does my line here cross the y-axis? Well, I've actually already used that point there, so it's difficult to see because I've already used it. So let me just get this and rub that out. If we look at where my line crosses the y-axis, it's here. This is the x-axis, this is the y-axis. That's another thing that students often get wrong, and they use the wrong point, but it crosses at -2. So my plus C is actually a -2. You don't need to write plus -2, it's just -2. So that is my final answer for this question. Y equals -3x, take 2. So if you had just y equals -3x, but a different answer here, that would actually get you 2 marks. If you had y equals something else x, take 2, you get a mark for getting the y-intercept correct. So you get a mark for the gradient, a mark for the y-intercept, and then a mark for having a fully correct equation. So that's worth 3 marks in total. Okay, let's have a look at question 8. Dwayne buys 20 rulers for 40p each. He sells 15 of the rulers for the same price. He makes a 50% profit on the price he paid for 20 rulers. Work out how much Dwayne sells each of the 15 rulers for. You must show all your working, so you have to show all your working out here to get all 4 marks. So let's start with the first bit of information he gives me. He buys 20 rulers for 40p each. So let's work out how much he's paid. 2 times 4 is 8. So 800 pence, which is the same, if you want to write it in pounds, as £8, as 100 pence in a pound. So that would get you a mark for working out how much he's paid. So he sells 15 rulers for the same price, and he makes a 50% profit on the price he paid for 20. Well, this is the price he paid for 20. So he's going to make a 50% profit. So first of all, let's work out what is 50% of £8 or 800 pence, depends on what you've done. 50% is just half. So half of £8 is £4. So he's going to make a 50% profit. So therefore, he's going to sell them for £12. The £8 that he spent plus his 50% profit that he makes, that's a total of £12. And he's going to sell all 15 rulers for the same price. It might actually help us to have this in pence. So let's put it back into pence, because we're going to have to divide by 15. So I've got to see how many, I've got to share this equally into 15, which is dividing. So I've got to share 12,000 pence into 15 equal amounts. So I'm dividing it by 15. I can't do 15s into 1 or 15s into 12, so I'm going to have to do 15s into 120. So sometimes it helps to have the times table written down the side. So I'm going to go 15, 30, 45, 60, 75, 90, 105, 120. So that's 1, 2, 3, 4, 5, 6, 7, 8 15s going to 120. So that tells me that he's going to sell each of his 15 rulers for 80 pence. So you'd get a mark here for working out how much he's paid, a mark here for working out how much he's going to sell them for, including his 50% profit. You'd get a mark for then dividing by 15 to show your sharing into 15, and then obviously 4 marks if you've got ATP with all the correct working that goes with that, because it says you must show all your working. So that's question 8 for 4 marks. Okay, so let's have a look at question 9. The table below shows information about the ages in months of the children in a nursery. So we've got the least age, which is the minimum. We've got the median, the upper quartile, the interquartile range. The upper quartile is the same as Q3. The interquartile range, that's Q3 minus Q1, gives you the interquartile range, and the range, which is the maximum minus the minimum. This gives you the range here. So you need to know that a box plot looks like this when drawn. So like that, and you do not draw the line through the middle. So this is always your minimum value, this is your maximum value, this is your median, this is Q1 lower quartile, and this is Q3 upper quartile. So we need to know all of these values. At the moment we have the minimum is 7, we know that the median is 22, we know that the Q3, the upper quartile, is 29. We don't know the maximum and we don't know the Q1. However, we're told that the range, which is the distance between the minimum and the maximum, is 25. So if I do 7 add 25, I will get my maximum value, which is 32. So this is going to be 32. I'm also told that my interquartile range, which is the difference between Q3 and Q1, is 15. So I know that Q3 is 29. So if I do 29 subtract 15, I'll get Q1, which is going to be 14. So this is 14. So the first thing you need to do is work out those missing values. That's quite a common question. So then once you've done that, you can then go ahead and draw your box plot. Again, check the scale, because they quite often like to use scales that don't go up in ones. This is quite nice because it goes up in ones. So I'm going to find 7, which is here, and I'm going to draw a line and just keep them all the same size. They don't have to be different lengths. So I'm going to go with 1 square here. Then 14, so I'm going to draw that there. Then I've got 22, which goes there. I've got 29, which goes there. You should be doing this with a ruler and a pencil. And 32 goes here. And I'm going to join up my box in the middle because that represents my interquartile range. And then I draw the 2 tails at the end. And that is your final answer. So if you've got it all correct, you get 3. If you've got 3 out of the 5 values correct, you'd get 2 marks, 3 or 4. And then if you've got maybe 2 points correct, you might get 1 mark. So that is it for question 9. Right, let's have a look at question 10. So you have been given 2 vectors here, and you've been asked to find out B, the missing value B. So you've been 2 vectors, and vectors are directions. It's not fractions, so don't draw a line in here. This is telling you I go 1 right, 7 down if you're doing it on a coordinate grid, and 17 right, 19 down. But I don't need to know that for this question. All I've got to do here is substitute, first of all, the values that I've been given into 4 lots of A minus 5 lots of B equals 2C. And that will then help me find B. So I've got to do 4 lots of A. Well, A, it tells me here, is 1, -7, minus 5 lots of B. Well, I don't know what B is, so I'm going to leave that like that. And I'm told that equals 2 lots of C, which is 17 and -19. So the substitution part will give you 1 of the 4 marks. And I'm now going to work out these 2 parts separately. So 4 lots of this, you times the whole vector. So you times the whole thing, not like with fractions where you'd only multiply the top. It's not a fraction, so you multiply both parts. 4 times 1 is 4. 4 lots of -7 is -28. Take 5B equals 2 lots of 17, which is 34, and 2 lots of -19, which is -38. For having either one of these correct here gets you your next mark. Now, because I need to work out what B is, I'm going to rearrange this. So I want this to be positive. So what I'm going to do is I'm going to add 5B to both sides of my equation. And what that will do is that will give me 4 -28 stays as it is. This is now 0. So I've got my equal sign, and I've got 34 -38 plus 5B. So by adding 5b to both sides, essentially you've got rid of it on the left and it's now positive on the right. Now, because I want 5b on its own, I'm now going to subtract this vector here. So if I subtract it from this side, I need to subtract it from the left-hand side as well. So you end up with 4 negative 28, take away 34 negative 38 equals 5 lots of b. So let's work out what this gives us first of all, and then we can work out what b is from there. So 4 take away 34 is going to give me, I'm going to write up here because I'm running out of space, is going to give me negative 30, and negative 28 take away negative 30. So when you subtract a negative, the answer actually increases. If you think about taking cold temperature out of a room and negative being cold, if you subtract the cold, the temperature is going to rise. So you're starting at negative 28 and you're going to increase by 38. So you actually end up with 10. Very common mistake there that people often get wrong. When you're subtracting a negative, you have to increase. Equals 5 lots of b. So if I now want to reverse this, instead of timesing by 5, to get what b is, I'm going to divide by 5. The opposite of multiplying by 5 is divide by 5. So negative 30 divided by 5 and 10 divided by 5. So that will give me negative 6. And, oh, see, I've made the mistake then. I've drawn a fraction. Easy to do. Don't do that. So negative 6 and 2 is my final answer. So negative 6, 2. It is not a fraction, so don't write a line in there. So you'd get a mark for, first of all, substituting. That would give you a mark there. And you'd get a mark for having one of these correct. Then you'd get a mark for rearranging your formula. So getting something like, and then the last mark is for dividing by 5 or getting your correct answer. So that's where your 4 marks would come from. Okay, so let's have a look at question 11. This is a transformation question. So it says here, shape A is rotated 90 degrees clockwise. Shape A is rotated 90 degrees clockwise, which is this direction, in the direction of the clock, about the point -1 to give shape B. Then shape B is reflected in the line y equals -1 to give shape C. Describe fully the single, that's important, transformation that maps A to C. So let's first of all do these transformations and step by step and see where we get to. So it's quite tricky to show you a rotation without being able to use tracing paper, but what I would do is I would have a piece of tracing paper and you'd put it over here, you'd trace this shape, and then you would put your pencil or pen in the point -1, which is down here, and you would turn your tracing paper 90 degrees, so 1 turn to the right. And when you do that, you'll see where that shape should end up. So I'm just going to rub this out so I can show you where that would be. If you do that with tracing paper, you'll end up with your shape end up rotated like that, and you would label that B, and that will get you a mark for doing that correct rotation. Okay, let's do C in a different colour. So shape B, so this shape is reflected in the line y equals -1. So y is here, y equals -1 is here, so the line y equals -1, lots of people think it goes downwards because y goes down, but it goes through y at -1, so that's the line y equals -1. X equals always come down this way, y equals go horizontally this way. So y equals -1, I've got to reflect shape B in this line. So it's currently 2 squares away. So I'm going to go 2 squares away in the opposite direction. So let's do C in green. So that line's going to be there. That's not green. Let's rub that out. and do it in green. So that's going to be there. And then this point here is 3 squares away. So I go 3 squares away in the opposite direction, and that would end up there. So there is my shape reflected in the line y equals what, -1. So I'm just going to get rid of these arrows now. So that's my shape. This is what you should have drawn on your diagram. So now you've been asked to describe the single transformation that maps A to C. So there's 4 types of transformations that you can have. You can have a rotation, which means your shape will have been turned, and you'll have a center of rotation, which will be a coordinate, and you'll have an angle and direction. And when you're describing transformations, you must not muddle this up or you don't get any marks at all. So that's 1. If it's an enlargement, it will have been made bigger or smaller, and you'll have a center of enlargement and a scale factor of enlargement. You've got a translation, which means it will have just been moved. It won't have changed size or shape, and you'll have a vector, which will tell you how it's been moved. And then you've got a reflection, which means it will be a mirror image in the line y equals or x equals. So you will have that. So let's have a look at these 4 and see which ones it could be. So rotation. Now, if I was to rotate this shape round, if you try that with some tracing paper, if you were to rotate this shape that way, you'd end up with the flat edge on the top, not at the bottom. Okay, same if you were to rotate it the other way. So it can't be a rotation. It's not been made any bigger or smaller, so it can't be an enlargement. If it's moved, it won't have changed the way up. So this is now upside down, so it can't be that one. So it has to be, the only one it can be is a reflection. So I'm going to write reflection, and even if you don't know the line of reflection, you leave it there. Okay, but we now need to get my next mark. I need to know the line of reflection. So it's always going to be a mirror image. So if you get some tracing paper, you can try and sort of map one shape onto the other. But I can see here that my line of reflection has to be a diagonal one for that to be. So then these points here are equal distance away either side of the line, and so are these points here. So the line of reflection has to be this line here. And if you look at the coordinates along the line, it's 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. So all the way along there, the y coordinate is equal to the x coordinate. So this line here is the line y equals x. So you can just put reflection y equals x, or in the line y equals x. And that's where you're going to get all your marks from. Let's have a look at question 12. So you have been asked to express this decimal as a fraction, and these dots here show you that those numbers repeat. So sometimes you'll be asked to do this algebraically, and it's a good idea to do it this way every time, as it sets the working out nicely, and gets you marks from the mark scheme. So the first thing you do is you show that you know what this number means and the 2 dots mean. So let me just rub that off so you can see the number properly again. So this means 0.07, and now because the dots are only above the 2 and the 4, that means only the 2 and the 4 recur or repeat, and it's a good idea to write them out at least 3 times and show that it continues. So that sometimes gets you a mark just for writing that out and showing that you know what the number means. So we now need to get this to be a whole number and get rid of the decimal so that I can write it as a fraction, because we don't have decimals in fractions. So the first thing you want to do is you want to get rid of these 2 digits here that don't repeat. So in order to do that, I would need to times this by 100. So I write 100x equals, and this would become 007, but I can just write 7.242424, and so on. Now, at the moment, the decimal of my original equation and my second equation, the decimal part are not equivalent. And I need those to be equivalent so I can subtract them and get rid of the part after the fraction. So I now need to make another equation, and this time I need to get rid of the 2 non-repeating digits and the 2 repeating digits. So there's 4 digits there. So I would need another equation, and I would times that by 10,000 x. So that would give me, if all of these digits were the other side of the decimal, I'd have 724.242424, and so on. So now if you look at the decimal part, in my 100x and my 10,000x, the part after the decimal is the same. So what I can now do is subtract these 2 equations. So 10,000x minus 100x is 9,900x. And when I do this, subtract this, the decimal part will cancel out. So I've only got to do 724 minus 7, which will be 717. So now that I've got rid of the decimal, I can write this as a fraction by dividing both sides by 9,900. So these then cancel each other out, leaving me with x equals 717 over 9,900. You don't need to simplify, even if you can, because it doesn't ask you to. And if you simplify incorrectly, you'll actually lose a mark. So unless it asks you specifically to simplify, then I would leave your answer like that. Let's have a look at question 13. So you've got a cafe menu, you've got 4 starters, 7 mains and 5 desserts, and you've got to work out how many possible combinations. So this is quite a standard question. This comes up most of the time on the higher paper. And because you're working out the combinations of starters, mains and desserts, you've got 4 starters, 7 mains, 5 desserts, so you would just multiply these together, because you can have these 4 with any of these 7 with any of these 5. So 4 lots of 7 is 28, times that by 5, or 28 times 10 is 280, so I can half it because I'm only timesing by 5, therefore there are 140 combinations, and that's it for that question. So let's have a look at question 14. I have been asked to solve this equation here. So the first thing that I would do is look at expanding the brackets. So I'm going to do 6x multiplied by 2x, which is 12x squared. This is where students often lose marks and then can't get any marks for the rest of the question. X multiplied by x is x squared. And then 6x multiplied by 3 is positive 18x, and that equals 11x minus 1. Sometimes you would get a mark for this, for expanding the bracket. On this question you don't. You have to then recognise that because it's got x squared in, which is a quadratic, and you need to solve it, you have to make it equal to 0. And the reason for that is, if I just show you a quick sketch of a quadratic graph is always a U-shaped graph, and your graph will be y equals something x squared plus something x plus something else. And this is your x-axis and this is your y-axis, and you'll notice that normally you'll end up with 2 solutions, not always if it doesn't cross the axis, but you end up with 2 solutions, so you get 2 values for x because it crosses the x-axis at 2 different points, and the equation of the x-axis is y equals 0. So when we equal it to 0, when we equal y to 0 and we solve it, we're finding the 2 points where my graph crosses my x-axis. So we need to solve this. We've got to make it equal to 0. So let me just get a different colour. I'm going to subtract 11x and add 1 because that will make this side equal to 0. So I need to do the same to the other side. So I'm just going to subtract 11x plus 1. I'm doing the same to both sides of my equation. So this side, 12x squared, will remain unchanged. So that's 12x squared. I've got 18x take away 11x, which is positive 7x. And then I'm just going to put my plus 1 on the end. This is now 0, which is what I wanted. So I've now got it equal to 0. And there I have got my first mark for making it equal to 0. So now, in order to solve this, the best way to do this is to factorise on a non-calculator paper if you can. So I'm going to put this into brackets, so I'll get 2 brackets. However, because I've got a coefficient, that means a number in front of x squared, coefficient of x squared greater than 1, I can't just go straight into the brackets unless you'd like to do that by trial and error. So the method that I like to use is I multiply this value by this value. So that's my A and my C. I multiply those together. So I'm going to do that over here. 12 times 1. So now I'm looking for 2 numbers that multiply to give me 12, that add to give me 7 here. And normally you'd look for 2 numbers that multiply to give you the number on the end and add to give you the number in the middle. But because I've got this coefficient of x squared as 12 there, I have to times the 12 and the 1 together first. So now I need 2 numbers that multiply to give me 12, that add to give me 7. So that's going to be 3 and 4. 3 times 4 is 12. 3 add 4 is 7. So what I'm going to do now is I'm going to swap my 7x here for a 3x and a 4x. 3x and 4x is the same as 7x. So it doesn't actually change the equation. It just splits it into 2. So I end up with 12x squared. And it doesn't matter which way round you put the 3 and the 4. Plus 3x plus 4x plus 1 equals 0. So the 1 stayed the same, the 12x has stayed the same, and I've just swapped my 7x squared for a 3x and a 4x. Okay, so now what I do, I'm going to do this in a different colour, is I split my equation into 2, and I'm going to factorise each side of this line with a single bracket. So I've got 12x squared and 3x, and my highest common factor of 12 and 3 is 3, so I can have that on the outside of the bracket. They've both got x in, so I can put that on the outside. What do I multiply 3x by to get 12x squared? That's going to be 4x. 3 times 4 is 12, x times x is x squared. And what do I multiply 3x for it to stay as 3x? That's just going to be 1. 1 times 3x is 3x. This side, if I look, there is no number that goes into both of these other than 1. So I can just put a plus 1 there. You need to have a number on the outside of the bracket. So then this is all just going to stay the same for x plus 1 equals 0. Okay, so now what you should see is that these 2 brackets are the same, which tells you that you've done this correctly, which they are. So that forms my first bracket, 4x plus 1. And then whatever I've got left over here and here forms my second bracket. So this is factorising quadratics with a coefficient of x squared greater than 1, which you might need for other things as well. So that is now factorised. And if you want to, you can check by expanding this out again to make sure it's correct. So let's have a go at that quickly. 4x times 3x is 12x squared. 4x times 1 is 4x. 1 times 3x is 3x. If you add those together, you get 7x. And 1 times 1 is 1. So it's correct. So now, remember, we get 2 solutions because it's telling me the 2 places that my graph, this graph here, crosses my x-axis. So I've got 4x plus 1 equals 0 is one option, and 3x plus 1, my other bracket, equals 0 is my other option. So I'm just going to solve these 2 equations here. So I would, if I was solving this one, I would subtract 1 from both sides, which gives me 4x equals negative 1. And then I would divide by 4, which gives me x equals negative a quarter. Here I would subtract 1 from both sides, and I end up with 3x equals negative 1. Divide both sides by 3, x equals negative 1/3. So they are my two solutions. So that's it. I would write my answer. I said x equals -1/4, x equals -1/3. And that would get me my full 4 marks. You get a mark here for equaling it to 0. You'd then get a mark for factorising correctly, ignoring the signs, as long as you had the numbers correct. Then you'd get a mark for solving one or the other. And then if you got both correct, that would give you all 4 marks there. So that's question 14 for 4 marks. Okay, let's have a look at question 15. So here is triangle ABC. Show that x can be written, so x is here, in the form d, so a number, square root e, another number. And d and e are integers, that just means they are whole numbers. So we should know that integers means whole numbers. You need to know that. So I'm going to have two different numbers here when I work out the value of x. So let's think about, if I had to work out the value of x, how would I do it? So I've got a non-right angled triangle and I'm working out a length. So in a non-right angled triangle, you can either use sine or you can use cosine. Okay, so if it's right angled, you're looking at SOHCAHTOA or Pythagoras, but because it's non-right angled, it's sine or cosine. Now, to use sine rule, you need to be able to make a cross in your triangle with a side and an angle, side and an angle being opposite each other. Cosine rule, you need to be anything with 3 sides involved. So that could be, you've got 2 sides and you're finding the 3rd side, or you've got 3 sides already and you want the angle. So if we look here, we've only got 1 side and we're finding the 2nd side. So it can't be cosine. So it's got to be sine. So let's see if we can make a cross, because sometimes you might need to work out the other angle up here. But let's have a look. So I've got, there's my side and my angle opposite each other there, and there's my side and my angle opposite each other there. So I don't need to work out this angle up here. If it was this side here, I would need to work out this angle, but I don't need to do that for this question. So the sine rule is given to you on the formula sheet, and if you are using it for a side, you write it this way up. A over sine A equals B over sine B. If you were asked to find an angle, you can flip this formula upside down, but we don't need to do that because we're finding a side. So let's say that A is x. So you can ignore the letters on the triangle, it doesn't matter. As long as in your formula, your little a is the length and your big A is the angle, and they are opposite each other. So we're going to say x is little a, and my angle here of 45 is my big A, because they're opposite each other. So therefore 11 will be my little b, and this angle over here will be my big B, because they're opposite each other. So you don't have to use the letters that are given to you on the triangle for the formula. So A is x, and I'm going to put sine of 45 here, equals B, which is 11. And the angle opposite that is 30, so sine 30. So I've now got to rearrange this to work out what x is. I've got to times by sine 45 to get rid of it on the left-hand side. So I have to times by sine 45 on the right-hand side. So what that does is timesing and dividing by sine 45 cancels them out. So I'm left with just x. And I'll end up with 11 times by sine 45 over sine 30. So you'd have some marks up to here. Now what you need to know is the values of sine 45 and sine 30. So I like to use the fingers method. There's lots of different methods. There's a table that you can learn. But basically, if you're doing sine, you have your hand. I'm going to attempt to draw a hand here. So this is my thumb, and then I've got these fingers here. Very strange, alien-looking hand. But anyway, so when you're doing values of sine, you have this finger here is 0, this finger here is 30, this is 45, this is 60, and this is 90. Okay, so when you're doing sine, and this will make sense in a minute if you don't know how to do this, this is the square root of the fingers below over 2. If you're asked to do values of cos without, so that's for sine. If you're asked to do values of cos without calculator, do the square root of the fingers above over 2. Over 2. Okay, and tan is slightly different, but we won't look at that in this example. But we're doing sine, so we're doing square root of the fingers below over 2. So let's take out these values separately. So I'm going to do sine 45 first. So if I look at 45, that's here. So below, the number of fingers that I've got below my sine 45 is 2. I've got these 2 fingers here. So the square root of the fingers below, so square root of 2 over 2. And that's it. Okay, you can't simplify that because they're not both square roots. You can't divide root 2 by 2, so you leave it like that. Right, now let's look at sine 30. So sine 30 equals, and again, if I now look at 30, which is here, this finger, I've only got one finger below 30. So it would be the square root of 1 over 2. Now the square root of 1 is just 1, so that is a half. Sine 30 is a half. So now let's break this down over here. Obviously in your exam you'd write a bit smaller than this. I've run out of space, so luckily I've got this bit of page over here. So I'm going to do the top of this fraction here first. So 11 times by sine 45, which we now know is root 2 over 2. So that just gives me 11 root 2 over 2. Now I've got to divide that by sine 30. So I'm going to write 11 root 2 over 2 divided by sine 30, which is a half. Now dividing by a half is the same as timesing by 2. So I just flip this fraction upside down. I can write the 1 at the bottom. I don't need to. Dividing by half is the same as timesing by 2. So now I'm going to work out my final answer. 11 root 2 times 2. Well, 11 root 2, you do this in the same way as you would do with letters. It's very similar with surds. These are called surds, roots, irrational numbers. So I've got 11 root 2s. Imagine you had 11 x's there. If you times that by 2, you'd have 22 x's. So I've got 22 root 2s. So 2 lots of 11 root 2 is 22 root 2. And 2 times 1 on the bottom is just 2. I can then divide. Now you can't divide the root 2, just like if you had an x there. Okay, so you keep the root 2 as it is, but you can do 22 divided by 2. And your final answer is 11 root 2, which gives me something like this. So D would be 11 and E would be root 2, but you just write your answer as 11 root 2 for all 3 marks. And that is question 15. Have a look at question 16. So I've got to solve this equation here, which has got fractions and algebra. So I'm actually going to write it out again here so we can see what we're doing. So I'm just rewriting out the question. So the idea here is we need to, in order to get rid of the fractions, to make this easier to solve, I need to get rid of the denominators. So basically, I need the denominators to be the same. So if I just look at the left-hand side here and work this side out first, if I wanted these 2 fractions here to have a common denominator of 15, because 3 and 5 both go into 15, I would have to times this fraction here by 5, and I would have to times this fraction here by 3. So let's do that. That gives me a denominator, and whatever you times the bottom by, you have to do the same to the top, otherwise it's no longer an equivalent fraction. So if I times the bottom by 5, that's 15, and if I times the top by 5 lots of 4x is 20x, and 5 lots of 2 is 10. My minus here, and then if I times this side by 3, top and bottom, the 3 times 5 is 15. 3 lots of 5x is 15x, and 3 lots of 6 is negative 18. I'm going to put this in a bracket because you're actually subtracting all of this when you work out this sum here. Then I've still got my 10x plus 3 over 15 on the right hand side. So let's work out the left hand side and simplify this. So I'm taking, because the denominators are the same, it remains the same. And I'm doing all of this, subtract all of this. This is one whole term here that I'm taking away from this, one whole expression, sorry. So I'm going to do 20x, take away 15x, which is 5x. And this is where students often go wrong. I've got to do 10, take away negative 18. And we had this earlier. When you subtract a negative, it's like taking away the cold. You take the cold temperature out of a room, the temperature is going to rise. So when you subtract a negative 18, you're actually increasing. So if you start at 10 and increase by 18, you're going to get positive 28. And if you make a mistake there, that obviously stops you getting the rest of the question correct. However, up to this point here, for having either one of these fractions correct would give you a mark if you've done that. Okay, so now we're here, because both sides have got a denominator of 15, I can actually cancel those out, and I'm just going to do 5x plus 28 equals 10x, add 3. What I've essentially done is times both sides by 15, and it's cancelled out the denominator of 15. So now I have an equation which is much easier to solve. So when you've got x's on both sides, the idea is to get rid of the smaller x first. So in order to get rid of this, I need to subtract 5x. And so therefore I have to subtract 5x from the right hand side as well. So 5x take away 5x is nothing, which is what I wanted. I wanted to get rid of it. I've got 28 left. 10x take 5x is 5x, and then I've got plus 3. So now I need to get x on its own. So I need to get rid of this 3. So I'm going to subtract 3, which is the opposite of add 3. And then I do the same to the other side. So I get 25 equals, and then that's 3 minus 3 is nothing, so I'm left with 5x. Now when you get it to this stage, some people prefer to rewrite it the other way around, which is fine as long as you keep everything the same. It's the same equation, just written the other way around. So 5 lots of x is 25, so 1 lot of x you divide by 5 is 5. And that is the final answer for question 16. So you'd have a mark for here. You have a mark for then simplifying and getting rid of your denominator. And then you'd have a mark for isolating in terms of x. And then obviously you'd have a mark for having a correct answer of 5. Okay, let's have a quick look at question 17. So I've got to find the coordinates of the turning point of this graph here. So that's quite a common thing that they ask you to do on a higher paper. And if you need the coordinates of the turning point, you need to complete the square. And that's just another method of factorising, complete the square. So that's what we're going to do here. Now, because I've got a coefficient of x squared that's greater than 1, so a number in front of x squared that's greater than 1, I need to take that out first. So I'm going to take it out and I'm going to put a square bracket to remind me I've still got to complete the square. So if I divide x squared by 5, if I divide 5x squared by 5, I get just x squared. If I divide 4x by 5, I get 4/5 x. So all I've done is I've divided this part by 5 and put 5 on the outside, and you can leave the plus 9 on the outside, and we'll deal with that at the end. So now I've got to complete the square with what's on inside this bracket here. So I'm still going to keep a square bracket to remind myself that I still have to expand back out again at the end. So I'm going to complete the square with this part here that I've got here. So in order to do that, I have an open bracket. I have x plus or minus, so it's plus here, and I have to half the coefficient of x. So I have to half this number here in front of x. So I've got to do half of 4/5. So it's the same as doing half of 10. I'll just show you. So half of 10, that gives me 10 over 2, which is 5. So half of a number, you just times it by half. Works the same with fractions. So 4 times 1 is 4, 5 times 2 is 10, so 4/10, and I can simplify that down to 2/5 just to make the numbers a little bit easier to deal with. So I'm going to put plus 2, I've used a different colour there, so let's get rid of that. So it's half 2/5 squared. And then, so once you've halved the coefficient of x, and it always goes in the bracket and looks like this, you have to subtract the square of half the coefficient of x. So the square of this here. So 2/5 squared, basically, which is 2/5 times 2/5, which is 4 over 25. So that's going to be 4 over 25. So that's this expression here. I've completed the square. So I halved the coefficient of x, and it went here. You always have x bracket squared here, and you subtract the square of the number that you have here. So now, because I've got this 5 on the outside, I've got to expand it back out again. So with the bracket, I can just put it at the front and leave the bracket exactly as it is, like this. And I've got to now do 5 times 4 over 25. So when you times, that's essentially 5 over 1. So you end up with 20 over 25. And don't forget, you've still got this plus 9 over here. So the last thing I've got to do is work out what minus 20 over 25 plus 9 is. So let's do that over here. Minus 20 over 25, add 9, which is currently over 1. So I'm going to make that minus 20 over 25. And if I put this over 25, I've timesed it by 25. So I've got to do 25 times 9. 9 5s are 45. 9 2s are 18, plus the 4 that I've got here is 22. So that gives me 225 over 25. So if I do negative 20 over 25, add 225 over 25, I end up with this. So I've got this all stays the same. And then minus 20, add 225 gives me positive 205 over 25. So I've now completed the square, I've finished that, and now to get the last bit, which is your turning point, you reverse the sign of whatever's inside the bracket and you keep this one outside the same, and this will be your x coordinate and this will be your y coordinate. So it's positive 2/5, so I'm going to write negative 2/5. You always reverse the sign of what's inside the bracket, and then my y will be 205 over 25. You do not need to simplify, you will still get full marks. The mark scheme says OE or equivalent, so any equivalent answer. They've simplified it down to 41 over 5, but that is the same as having 205 over 25. So that is it to give you a full 4 marks. Let's have a look at question 18. It can be quite tricky, this one, the way it's worded. So let's try and break it down. So we've been given in bag A, the number of white counters to red is 7 to 3. And you're dealing with probability here, and they've given you a ratio. So the first thing I would do here is write these as fractions, because probability we use fractions. So I've got white counters to red counters. So there are 7 white and 3 red. Therefore, the probability or the fraction of white is 7 out of 10, which is the total of 7 plus 3, and red will be 3 out of 10. So that makes it a bit easier for dealing with the rest of the question. Okay, in bag B there are 9 white and 2 red. In bag C there are 11 white and 4 red. So Faisal takes a random counter from bag A, then puts the counter into bag B. That's important. He then takes a random counter from bag B and puts it into bag C. Find the probability there's now an even number of white counters in bag C. So you're going to need to work out probability here, and we're going to need to work out which ones to do. So I'm going to start by helping us visualize this by putting it in a tree diagram. So let's look at bag A. In bag A, I have both white and red, and the probability that I take a white from bag A is 7 out of 10. We know that because I did that up here. And a red is 3 out of 10. Now the next bit of information that was important was that Faisal takes a counter from bag A and puts the counter into bag B. So when I come to take a counter out of bag B, it will have had another counter put into it from bag A. So let's have a look. There's 9 in, let's do bag B. I've got 9 white, 2 red, which is a total of 11. However, you're going to have a counter from A put into B. So you're going to actually end up with 12. And the white and red are going to depend on what you've picked from A. But we know, this is the key here, that these, when you take from here, is going to be out of 12 because it'll have had a counter put into it from bag A. So if you take a white counter, let's put white, red, white, red. If I take a white counter from bag A, there were 9 whites, but I've took a white from A, so there will be 10 whites. If I took a white from bag A, the number of reds will remain the same, but the total, obviously, we know has gone up to 12. This is if I take a red counter from A first time round, so therefore the whites will remain as 9, but the reds will increase to 3 because there were 2, and that will go up to 3. So we want to know, we're going to pick from A, pick from B, and then they're going to land up in C, and we want to know the probability is an even number in C of white counters. So in bag C, we've got 11 white and 4 red. So the only way we're going to end up with an even number in bag C is if we take a white from bag B, because then it will take that up to 12. If you take a red from bag B, this would stay at 11. So therefore, we're looking at the options where you end up taking a white from bag B and putting it into C. So we can do white, white, because white from A, white from B ends up with a white going into bag C. We can't do this, white, red. We can do white, white, because that ends up with a white from bag B going into C, taking that up to 12. If we take a red from B and put it into C, that's no good, so we can't do this one. Red, white works, because we're getting a red from A, a white from B. Remember, we need a white from B to make C have an even number of white counters, and red, red is no good. So now we can work out the probability of white, white, or we could have red, white. So when it's or, you add the probabilities together. And to get the probability of white, white, we times the probabilities together. We times along the branches of our tree. So white in A is 7 out of 10. White in B will be 10 out of 12 to take a white from B. And then if I do red, white, red from A is 3 out of 10. To then take a white from B is 9 over 12. So this is what I'm working out, because that's the only two options where I end up with an even number of white in C at the end. So 7 times 10 is 70, 10 times 12 is 120, 3 times 9 is 18, and 10 times 12 is 120. So when I add them together, I get 98 over 120. So that's my final answer for 4 marks. But the question makes it a lot more complicated because of the amount of information I'm given and the way that it is worded. Okay, let's take a look at 19. Again, I'm going to write this out a little bit bigger so we can see what we're dealing with here. So we've got to find the value of x. These are really common questions, and you need to have your knowledge of indices, so powers, in order to be able to answer this. So if you're looking at these numbers here, you can see that you can make them all 3 to the power of something. Okay, and they're quite common. You need to look out for that sort of question. So 9 I can rewrite as 3 squared. I'm going to put a bracket because I've still got this 2x here. That doesn't disappear. Okay, and then 27 I can write as 3 cubed. 3 times 3 is 9, times by 3 is 27. And I've still got my 2, hence why I've got my bracket. 81 can be written as 3 to the power of 4. 3 3s are 9, 3 9s are 27, 3 27s are 81. And again, a bracket because I've still got my 3x minus 2. Now this, I want to get rid of my fraction here. So I'm just going to get rid of that line. I want to get rid of my fraction. So if you've got a number written like this and you want to get rid of the fraction, you need to use the negative reciprocal. So this can be rewritten. 1 over 3 to the power of 18 is the same as writing 3 to the negative 18. So that's knowing your knowledge of negative indices. So I'm going to rewrite that as 3 to the power of negative 18 because that gets rid of the fraction. Okay, so that gives you your first mark. Even if you've got, I think it's 2 of these correct, you get on one of them correct, you get a mark for that. So now if I've got brackets, my rule when I've got brackets is that I multiply the powers here. I multiply these to get rid of the brackets. So let's do that. And I get 3 to the power of 4x times by 3 to the power of 6. Okay, question 20. Nearly there. ABCD, which is this outer shape here, is a parallelogram. AEFC, this line here, is a straight line. And we've got to prove that triangle ABE, so no, let's get rid of that. I thought that was E there, but it isn't. Nope, so we've got to go ABE, this triangle here, is congruent to CDF, which is here, CDF. So I've got to prove that those 2 triangles are congruent, which means the same or identical. So in order to prove 2 triangles are congruent, you have to prove that either they have all 3 sides exactly the same, side, side, side. You have to prove that you have side, angle, side in common, or angle, side, angle. So 2 sides and an angle, 2 angles and a side, or 3 sides the same. So we need to have a look at what we can prove there. So we've already got that this angle here and this angle here is 90. So we already know they've got an angle in common. So it's likely to be one of these bottom 2 here. So let's write that first of all. So this is angle BEA, or you can call it AEB, depending on which way you go. So I'm going to go AEB. Angle ABE is equal to angle, and let's go CFD, CFD, and I'm putting an angle sign over the middle letter, and both are 90 degrees, and we can see that from the diagram. That's my first reasoning there. Okay, let's have a look at what else information I've been given. So I've been told that this whole shape on the outside is a parallelogram. Now, we know that opposite sides of a parallelogram are equal in length, so they'll be equal in length, and So will these two here. So there we go, we've got another side there in common. So I can put BA is equal to CD, opposite sides of a parallelogram are equal in length. That's my second reasoning there. So I now need, I've got an angle, I've got a side, so I either need another side or another angle that they've got in common. The other thing that I know here, because I have got a parallelogram, if you go like this here, because these two sides are parallel, you have these two are alternate angles, so they will be equal. So we've now got angle BAE is equal to angle ECD because they are alternate. Let's just move my page down so you can see what I'm writing. They are alternate angles are equal, and your reasoning is really important when you're doing proof questions. That's part of the proof. So there we are. We have this side is equal to this side. This angle here is equal to this angle here. And this angle here is equal to this angle here. So we have angle, side, angle in common. So we have enough there to prove that those two triangles are congruent and get all my marks. Here is question 21A, and we have been given a function here. This is the function. Y is this function here that's drawn on the graph, and I have to draw the negative function. So there's a few rules that we need to know here. So when you have a function, anything that's outside of the bracket where x is always to do with your y coordinate. So it's going to affect our y coordinate in some way. If I had it inside the bracket like this, it means it would be affecting my x coordinate. But when it's inside the bracket, we always do the opposite action. Whereas when it's outside the bracket, it's to do with y, we do the same action. So you could have something like this, f of x plus 7, for example. So it's outside of the bracket. That's telling me, and I'm going to do the same action. So that's telling me to add 7 to my y coordinate. If I had something like this, it's inside the bracket, so it's to do with x, but I'm doing the opposite. So instead of adding 7 to my x coordinate, I would subtract 7 from my x coordinates. So, however, this is this here, the function that I've got is like having a -1 f of x, like that. So because the -1 is here at the front, it's telling me to multiply rather than something like this where I would be adding or subtracting. Here, this is like -1 multiplied by my function. But because it's to do with the y coordinate, this is telling me to multiply my y coordinates by -1. So what's going to happen there is all of my y coordinates are going to become multiplied by -1, so it will reverse the sign. So if I've got a y coordinate here of +2, this coordinate's got a y coordinate of +2, it will become -2. So it will end up down here. This here, my y coordinate is 3, so it becomes -3 when I multiply that by -1, so it ends up down here. This here, my y coordinate is -1, so when I multiply that by -1, it becomes +1, so it ends up here. And then lastly, this coordinate here, the y is 1, but it when it's multiplied by -1, it becomes -1. So actually, it affects y, but it ends up being a reflection. It affects the y coordinate, but it ends up being a reflection in the x-axis. And that's what your graph will look like. Equally, if you had something like this, it affects your x-coordinate, but it ends up being a reflection in your y-axis because the x-coordinate goes from being positive to negative and vice versa. But this is the correct answer for this graph. When all of the y-coordinates have been multiplied by -1, it reflects the graph. So let's have a look at part B. So we have the graph of y equals cosine of x. So you are expected to know certain properties of this graph. So this will be going from 0 to 360 on the x-axis. And the cosine graph goes up to 1 and down to -1. So you're expected to know certain properties of trigonometric graphs for questions like this. So you're given point P here, which has a y coordinate of -0.5. So you would be expected to know that at this point your x coordinate is going to be 120. So that would be your starting point for 1 mark. Now, the graph has been transformed to give this graph here. So bearing in mind what we looked at in part A, there's 2 things happening here. There's something inside the bracket that's going to impact the x-coordinate and outside the bracket that's going to impact the y. Now, if you remember, inside the bracket affects x and we do the opposite action. So this is telling me to subtract 60. So what I'm actually going to do to my x coordinate, which is here, is I'm going to do the opposite of subtracting 60, and I'm going to add 60. So that will give me 180 as my x coordinate. Now let's look at y, because I've got something outside the bracket here that is telling me to do something that's going to impact my y coordinate. And when it's y, which is outside the bracket, we do the same action. We keep it the same. So this is telling me to add 2. So if I add, so that's exactly what I'm going to do. I'm going to keep it the same. I'm not going to do the opposite. I'm adding 2 to -0.5. So I end up with a y coordinate of 1.5. And that is my answer here. I'd imagine you'd get a mark for each coordinate being correct. Yeah, 3 marks. So we need to obviously then put that down here on the answer line. So that is that for part B of that question. Okay, so last but not least, question 22, the final question. We have completed the paper. Very common this to have surds and rationalising surds on the paper, normally at the back end as well, because this is quite a tricky one here. But something easy to remember to pick up 1 mark, even if you're going for sort of your grade 6s. So because I've got to get it like this, if you notice you've got a D at the bottom, which means there are no surds. So that is why it's telling me to rationalise. If you're rationalising, you are getting rid of the surd or the irrational number in the denominator. So if I've got something like this, I'm going to rewrite it out so it's easier to see what we're doing. For 1 easy mark, you always multiply the top and bottom by the reverse of the denominator. So I'm going to write root 27 minus 4, because that's the reverse. This is plus 4, this is minus 4. This is using your knowledge of the difference of 2 squares to remove that root there. And whatever you multiply the bottom by, you have to do the same to the top, otherwise it would no longer be an equivalent fraction. So you always look at the denominator, because that's what we're trying to rationalise, and you reverse the sign here. We're now using our knowledge of the difference of 2 squares. So we can do this the long way. I'll show you the long way. We're going to need to do the top and the bottom. I know some people like to use a box like this. So let's start with the top. We'll do this in green, and we're going to do a grid like this. So I've got root 3 plus 1, so I'm going to write root 3 plus 1, and then I've got root 27 minus 4. That's the top two that I'm multiplying out here. So I've got to do root 3 times by root 27. Now my advice here would be to simplify root 27 first, because that can be simplified and that is a mark on its own. So you need to look at, have I got any square numbers that go into here? And if so, what's the highest square number that goes into there? So I can do the square root of 9 multiplied by the square root of 3, because 3 times 9 is 27. Square root of 9 can be simplified, so this becomes 3 times square root 3, which is just 3 root 3. So that is a mark on its own, just for simplifying. So you've got a mark here, or just remembering to multiply the top and the bottom by the reverse of the denominator, and another mark here for simplifying that root 27. So I'm going to write this as 3 root 3 underneath. So now I've got to do 3 root 3 multiplied by root 3. Now you should know that root 3 times root 3 is just 3. Because root 3 times root 3 is square root 9, square root of 9 is 3. So, and then I times that by the 3 that I had at the beginning. So I just get 9 here. Then I've got 1 times 3 root 3, which will be 3 root 3. Negative 4 times root 3 is negative 4 root 3. And then 1 times negative 4 is negative 4. So that's my top part of my fraction there. And then if I simplify this, 9 minus 4 is going to be 5. And then I've got 3 root 3s minus 4 root 3s, which is negative 1 root 3. A bit like having 3x take 4x, you'd have negative 1x. So that's the top done. Okay, so let's do the bottom in a different colour. Let's go with blue. We'll do the bottom. You can do the bottom in a quick way using your knowledge of the difference of two squares, but I'll show you this way first. So you've got root 27, but actually we now know, so we won't write root 27 because we've simplified root 27 over here to, we've simplified that to 3 root 3, and then I've got plus 4. And then I've got root 27, which is 3 root 3 minus 4. So I'm going to multiply this out now. So I've got to do here in this top left box, 3 root 3 multiplied by 3 root 3. So if I do 3 times 3, that's 9. And then root 3 times root 3 is just 3. So that is going to be 27. So equals 27. Sorry, it's one of my messages from my phone popping up there. So that equals 27 there. And then I've got to do 4 times 3 root 3. So I just do 4 times 3, which is 12. So it'd be 12 root 3. The root 3 remains unaffected. Negative 4 times 3 root 3. Well, negative 4 times 3 is negative 12. Again, the root 3 remains unaffected. And you can see here, these are going to cancel each other out. And that's because we used the reverse operation here. And then 4 times negative 4 is negative 16. So now all I've got left to do, negative 12 root 3, add root 3 is nothing, which is good. We wanted to get rid of the square root. 27 minus 16 is going to be 11. So I'm left with 11 on the bottom here. And now I've got an answer that looks like this. So yeah, so the quick way, just to show those of you that are interested of doing the bottom, if you think about the difference of two squares, if I have something like x squared take 16, we should know that factorises to x plus 4, x minus 4. And the way we get that is by if I square root 16, I get 4, and if I square root x, I get x, and I've got two different signs here. So if we're going the other way and we want to go from this back to this, you just square the first term, which is x squared, square the second term, so 4 squared is 16, and difference of 2 squares will always have a minus. So if I apply that here, root 27 squared is just 27. 4, so I've got 4 and 4. 4 squared is 16, and I'm going to put a minus in the middle, and 27 minus 16 is 11, so you can remember, use that way to quickly expand the bottom without having to do a box. But if you forget that, you've always got this method here that you can use. So that is my final answer there for 4 marks, and that's it. That is paper complete. So if you found that useful, please give us a like in the comments so that other people can find this paper as well. And if you've got any questions at all or anything that needs explaining, then please let me know. Thanks for watching.